Okay, so we left off with number 6, where we have the formula C2H6. So similarly to the last problem, we're going to go through and try and figure out whether it's categorized as an alkane, alkene, or alkyne. So the first thing is to figure out what the N is. And so here if we see that the N is 2, because there's 2 carbons, and the number of carbons is always the N value. So if we have 2 carbons, and we plug that into this formula where it's 2 times 2 plus 2, we get C2H6, which is an alkane. So we know that it's an alkane. If you could try it for the alkene, you would get C2H4, and if you tried it for the alkyne, let's do it for the alkyne down here. We have C2, and then again we're plugging in 2 for N, so it would be 2 times 2 minus 2, which would give us 2. So it fits the alkane formula, so it is an alkane. And what that means is it has all single bonds, just like ethane, this example that they show us. So we're going to go through and draw it. It says there are 2 carbons. We know that there are single bonds between them. And then we have 6 hydrogens around it. So I'm just going to put little lines for hydrogens. You could write the hydrogens in if you want. And let's go through naming this. So we have 2 carbons, so we know that our prefix is F. And we know that there are single bonds between the carbons, so we know that the ending is going to be ane. So this is ethane. And there we have it. Just to quickly quiz you on saturated or unsaturated, which molecule is saturated? Is it ethane or is it ethene? So the saturated hydrocarbon is ethane because it is full of hydrogens. It is fully saturated. You cannot add any more hydrogens to this molecule because all the carbons have 4 bonds. And so this is as much hydrogen as you can get. And we know that alkanes are always, saturated, and we know that alkenes and alkynes are always unsaturated. So our ethene, this guy, is saturated, and this guy, ethene, because it falls under alkene category, you can still have more hydrogens on this molecule. If you broke one of the double bond, just one of them, then you could have more hydrogens coming off. So it's unsaturated. Alright, let's try some more practice problems. Okay, so I have 2 more problems here. And we're going to start with number 7. So we have the formula C9H16. So my first question to you is it an alkane, an alkene, or an alkyne? So you have to figure that out based on the formula, the general formula I gave you, which general formula it best fits. So let's go for it. So we know that our N is 9 because next to all the C's, the N is what's written right by it. So we know that it is 9. So I'm going to just start off and write C9, C9, and, and C9 for my work for alkyne down here. Just to show you that, I'm going to draw an arrow. So all of them, the N is 9. So that's the key thing that tells us whether it's an alkene, or alkyne is based on how many hydrogens there are, not based on how many carbons there are. You can have a 9-carbon chain alkane, you can have a 9-carbon chain alkene, and a 9-carbon chain alkyne. So we need to figure out, based on the number of hydrogens that this general formula gives, does it match with how many hydrogens are up here? So we know our N is 9, so now we have to figure out how many hydrogens we would have if it was an alkane. So I'm just going to plug 9 into where the N is right there. So 9 times 2 is 18, plus 2 gets us 20. So if the compound is an alkane, the formula would be C9H20. So we would have 20 hydrogens. If we go up, we do not have 20 hydrogens. So there's no way this compound is an alkane. It is not all singly bonded. Alright, so let's try alkene. So we know that our N is 9 because that's how many carbons we have. Sorry, my 9 isn't very pretty. So let's see how many hydrogens we would expect to have if it's an alkene. So based on this little formula here, it's just 2 times N, so 2 times 9, and 2 times 9 is 18. So we would have C9H18. And that would be our general formula, and if we go up, we see we do not have C9H18, it's H16. So, well, that pretty much tells us it has to be an alkyne, but let's just double check our math here. So, if we plug in for this one, we know we have C9, so when we're plugging in 9 for N on the H side, 2 times 9 is 18, minus 2 brings us to 16. So our H is 16. So that is in fact the same formula as shown in number 7. So this has to be an alkyne. This is the winner. It's a triple bond. When I say it's an alkyne, that's just the category. It just means that it has a triple bond somewhere in it. When I say it's an alkene, that's also just the category. It means there's a double bond somewhere in it, and alkane is the other category, and that's just single bonds only. So we figured out that it is an alkyne by using the formula. Again, notice how all the carbon numbers are the same. They all were 9. The key thing is how many hydrogens there are, and you just figure that by plugging in your N number, which was 9 because of how many carbons we had, into each of the little formulas. And the one that matched was the last one. So we know we have a triple bond in this guy. You might say, well, how do I know where it is? And that's a fabulous question, and we're going to address that question on the next level. But for now, let's just put it wherever we want to put it, alright? Because the world is our oyster. So I am just going to draw a 9-carbon chain, and I'm going to decide that I want to put it in the middle, because why not? That is the worst triple bond I think I've ever drawn. To be fair, this is my first time drawing them, but you know. Okay, 1, 2, 3. So that's 1, 2, 3, 4, 5, 6, 7, 8. That it doesn't look like a carbon to me. And then you can do this, you can just draw it down, and instead draw the hydrogens to the side. So that is a 9-chain carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, with a triple bond somewhere in it. And of course, we know that each of these carbon guys needs 4 bonds. So let's add the little lines for the hydrogens. So the first guy is going to want 3, because together that makes, these make 4. This guy's only going to want 2. This guy's going to want 2. How many does this one want? Yep, it does not want any more because it actually already has 4. 1, 2, 3, 4. This guy also has 4. 1, 2, 3, 4. So no other lines coming off those guys. And then here you could have 2 more. Here you could have 2 more. This guy you could have 2 more. And then this guy 3 more. Alright, let's name it. So we know already that it is an alkyne. So the ending is going to be -ine. I know this is like retro doing it, but let's just write the ending because we figured that already. And we know that it has 9 carbons. So it's going to be nonine. That is the weirdest name, but that is what it's called. Nonine. I know I said I was going to do this in the next level, and I will, but just briefly, because it's easy, so we might as well do it. This triple bond is on the 1, 2, 3, 4th carbon, so we're going to say it's 4 nonine. Whoa, that is a bad 4. Alright, so that just tells you where the triple bond is by you putting a 4 there. Again, I will spend more time talking about this later. If you just had nonine, that's fabulous. Okay. In the second example, we have a compound, and I didn't draw the hydrogens around it, so I'm going to do that really quickly. This guy needs 3 more. The middle one only needs 1 more. And the last guy needs 2 more. Alright. So normally you draw them like up, down, that's up, down, sideways. When you have a double bond like this, you can draw them like slanted like I did. You might think I just can't draw. That was done on purpose. Again, that has to do with the orbitals and how they're bonding. If you drew them side and down, that's fine. Okay, so let's figure out what the name of this one is. So we have 3 carbons, so the prefix is prop. We have a double bond, so the ending is -ine. And that's it. Alright, well, we could also write the general formula. Again, you can just go through and count the number of hydrogens, but let's use the formula because now we know how to do it and counting is annoying. I'm just gonna quickly erase this stuff. So we know it's an alkene, so now we don't have to do it for all of them. We're just gonna do it using this one formula. And so we have 3 carbons, so our N is 3. Now that we know what this is, we can figure out how many hydrogens we have. It's just 2 times N, so 2 times 3 gets us 6. So our formula for propene is C3H6. This is the general formula, also known as molecular formula. The empirical formula would simplify down to C1H2. Okay, and also just a quick note that when I draw out the chain like this, like the picture, that is called the structural formula because you can see the structure. And this is the structural formula, whereas this way of representing it is called the general or molecular formula, because it's just telling you